Okay, Computer Science 40S students. Just bring this over. Our lessons and our class is all set up on our class for Computer Science 40S, including recordings of our live classes. And today's class will also get linked in here eventually as well, as I've kind of already mentioned. Yesterday, we created instances of our Husky, Piper, Doctor, and Baker. And we then outputted them using our built-in toString methods. We didn't write much code yesterday to make this happen, but we did do things like extend student and write a constructor method for high school, for Husky, for Piper, for Doctor, and for Baker. Some of these were very simple. Like for example, for the Baker class, all we did was we said extend person, and we added one line to our constructor. Now this is under the assumption that when you built these things, it used the template to automatically put in toString equals and clone. We're just not doing anything with toString equals and clone. toString automatically adds the word Baker or the word Doctor if you're using the template. So that when I run this, here's my Husky, which is a high school person. Here's my Piper, which is a high school person, okay? And high school extends student. So it's going to the student class and it's running its toString method, okay? Which adds the student number and stuff to it, which is why when it outputs the student number here, you can see it's a person. Then it outputs the student number. And I'm actually going to make a little reversal here on my student toString method. I'm going to put the student name here. Then I'm going to put the call to the superclass. You don't have to do this right now. I'm just doing this so that it kind of has a more consistent order to it. So now when I run this, when it outputs a Husky high school student with their student number, and let me actually put a space there as well. Okay. So Husky high school student, there's their student number, who is a person, and then the information about them as a person. Whereas a doctor is just a doctor who's a person, and here's some information about them as a person. Okay, so it's using multiple classes. Now, where this is interesting is in how we diagrammed this. So we diagrammed this in various ways yesterday so that you can see these check marks. We checked off that we wrote high school, we wrote Husky, we wrote Piper, we wrote Doctor, and Baker. We wrote those classes. We still have one to do, the Mr. Walks class. Here's what we know about Mr. Walks. It is a teacher. So it's going to be extending the teacher class. It's being used by our advanced classes test. So we have to build a Mr. Walks object, the same way we build a Husky and a Piper. The high school class was not used by the testing class. So we didn't make a high school object. It's just used through inheritance of the other classes. Okay, so let's go to our Mr. Walks class. Let's have it extends teacher. So the constructor that we used is no longer valid. We need a constructor for the Mr. Walks class. So I'm going to go to the teacher class to take a look at its constructor. So I'm going to open up 40S, source code, open up teacher, and take a look at this teacher class. Here's what the constructor looks like. Okay, so my Mr. Walks constructor would be similar. Public Mr. Walks, require a name as the one parameter it needs. To build a Mr. Walks, I'd have to build a teacher, and to build a teacher, I need a name. So how would I use it? Well, I can just pass it along to the superclass. If I was going to do more with the Mr. Walks class, I would add that stuff in there, but I'm not, okay? it's basically the same type of code, including the same type of comment here. I'm not going to put all this though. That's way too much what I wanted there. It's a class constructor. It just sets the class property name to the name of Mr. Walks. So Mr. Walks extends teacher means now, oops, put a check mark here that I've connected the Mr. Walks class to the teacher class, connected it into my diagram, but I got to make this connection as well. I haven't done like I've done here, that I've made a piper, made a husky, made a doctor, made a baker, right? I have done this connection. I've connected them, right, to their parent classes, but I haven't connected them to the class that uses them yet. So I'm going to go back now to the Advanced Classing Test class, and I'm going to build a Mr. Walks. Better import that. So Mr. Walks equals new Mr. Walks, and the name will be Mr. Walks. Yes, I am getting a kick out of saying my name multiple times right now. That's who I am. And I'm going to do a system out. Walks. Say it one more time with me, kids. Mr. Walks, Mr. Walks, Mr. Anyways, you get the point here. You guys have been talking to me. I haven't been hearing you. Now I can. My speaker had apparently gone to sleep. Woo! All right. So now I'm going to run that, and let's see what happens when Mr. Walks is outputted to the screen. And there it is. Mr. Walks teacher person is true. I could even add students to Mr. Walks. I'm not going to do this, but Mr. Walks dot, I could assign student 0 to be, for example, my husky object. A husky is a student. And then when I ran that, it would then output that student as part of the Mr. Walks, right? Like there's a student attached to Mr. Walks, a husky actually, okay? Actually, maybe I will add that in there. So just as fun, I'm gonna add a student object to that instance. Okay. Again, using some weird wording there. So I created objects and I added a student object to that instance of a Mr. Walks object. Okay, so I'm adding that student on there. So this is, again, multiple classes, all kind of getting, what is this? All kind of showing up here together in the diagram, right? If I show you the entire diagram right here, you can now see that this Mr. Walks class is one of many classes we've incorporated. Not these ones, because those are built right into Java, as is this one. But all of these other classes are ones we've written since the start of this course. And now you're kind of seeing how they can be connected to one another in various ways. That's the point of us learning about classes in a more advanced way. All right, now on to back to our checklist. The reason I've been doing this for our checklist is for the next two things we're going to be covering. This thing here called instance of, we're going to look at that in a second. It shows up here as well. And this concept of polymorphism, which I've already put a check mark on, but I'm going to take that check mark off for now. We're going to re-look at polymorphism in a slightly different way. With this class we haven't written anything with yet, the class called meeting, the meeting class. Okay? So that's what we're going to do. We're going to work on this thing called meeting right now. Okay. Apologies. Okay, so let's get started with our meeting class. So we're going to add some properties to our meeting class. A private, final, integer, the maximum number of people who can attend our meeting, max number of people Okay. Can attend a meeting. That's what this class is going to represent, a meeting of people. So there will be a maximum that int count. This is a regular variable, so it keeps count of how many people are attending. So there is a maximum, but this will keep a count of how many are attending. But now here's the more interesting one. We're going to make a person array, an array of person objects that we'll call the members of this meeting. This is me associating objects in an array. So remember how we said classes can connect to one another? Let me just show you this piece of that diagram again. Oh, it's so sluggish right here. Through inheritance, which we did when we did student is a person, but also association. So one class is just associating with another class. It's just using the other class. That's what's happening here. We're associating the person class with the meeting class. It's not inheritance. It's not like meeting extends person. That's not the case. Meeting doesn't have a parent class. It doesn't inherit from anyone other than object, but it associates with the person class through an array of objects. Okay, let's write our constructor now. By the way, we will not be needing toString, equals, or clone. So you can actually erase those. We won't need those methods. You can leave them if you want, but we don't need them. So now, what are we going to do with this meeting class? Well, we're going to set the max to be 100 people. Actually, let's make it 1,000 people. 1,000 people could attend this meeting, theoretically. The count, it's 0. Nobody's at the meeting yet. When we build a meeting, that's what's going to happen. 1,000 people, but right now we have 0 people. Now, before we continue our constructor, let's go back to our testing class. Okay. So we're going to instantiate and that's, again, just a fancy word for make an of a meeting. And it's a meeting object of that class. Class of that class. Okay, again, just using fancier words, but hopefully that's connecting with you now. So in other words, meeting equals new meeting. Make sure you import meeting. Okay. We have a meeting object. When it's created, it runs the constructor, the one we are just working on. So it sets the maximum, which is one of our properties, to 1,000. That cannot be changed. That is a constant property. And it sets the count to 0. So there is nobody in the meeting yet. However, this array has not yet been built. It has not yet been instantiated. So that's the next thing we're going to do. We now need to instantiate our array. So in other words, members, what we know about arrays, equals a new person object, and we'll set it to the max. So now that is the maximum number of people in our array. However, although the array has size now set up, and we're almost done. I'm looking at the time. All the index values, all the spots in the array are filled with nulls at this point. There's just a bunch of nulls in there. It's got 1,000 spots, but there's no actual person objects in there. No person objects, otherwise known as instances, are yet in the array. Nothing's in there. So we are going to fill the array with generic person objects. So let's loop through and fill up the array. For fun, let's use the enhanced for loop. Remember, that's read as for every member in members. You read that. Our member equals a new person. And we can just use the default constructor. Default person constructor method. Okay. That has filled the array with all these members. They're just person objects, persons. And it does that by just calling this method, just sets everybody to Jane Doe age 0, Jane Doe age 0, Jane Doe age 0. But it fills the array that way. Okay. Now, the reason we're setting up this meeting class is we will then be adding actual people into it. And I'm going to use that as a better way to explain the concept of polymorphism. And I'll explain this thing called instance of. I'll incorporate this into our example. Okay. But I'm going to wrap up today at this point here at 11:49, almost 11:50, so that tomorrow, remember, we will be working from 11 o'clock on. I'll be just sending the 30th students to work time, and you guys will be able to work from 11 to 11:30 from now on our example, which is great. I'm glad to be able to do that. All right, so I'm just going to say goodbye now to you guys for the day. Happy Tuesday. Enjoy the nice weather. Wait, let me turn off the recording.